Hello everyone, it's July 21st. Let's get the ball rolling. Alright, nothing of concern. What do we have? Push dominoes. Oh, look at this. Interesting. There are n dominoes in a line, and we place each domino vertically upright. In the beginning, we simultaneously push some of the dominoes either to the left or to the right. After each second, each domino that is falling to the left pushes the adjacent domino on the left. Similarly, the domino falling to the right. When a vertical domino has dominoes falling on it from both sides, it stays still due to the balance. Okay. For the purpose of this question, we'll consider that a falling domino expends no additional force to a falling or already fallen dominoes. We're given a string dominoes representing the initial state where domino I is the ith domino that has been pushed to the left. R will be pushed to the right, and this has not been pushed. Return a string representing the final state. Interesting. So the first two push to the right, this one push to the left. So these will balance, right? These will balance. Has been pushed to the right. So this will be balanced, and then this will be, will this be balanced by this, right? First domino expends no additional force on the second domino. So this is right, and just go right, and this will go right. This is the middle, and this will go left. That's okay. Second, we have this to the left, this is to the right. No push, left, right, no push, left. So afterwards, they both go left, right, 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 right. This one will stand still. So it will be, okay, stand still, right. Why is this one stand? Oh no, I was reading wrong. Here, right, right, stand still, left, left, right, right, left, left, because there's nothing in the middle, and it stands still, stands still. Okay, I think I know what it's talking about. So we have an initial state. 1, 2, 3, L, R, 1, 2, L, R, 2. So we have an initial state, and we want to find the final state, right? So if an initial state is stands still, then they do not move by themselves. They have to be moved by others. So we look for the left and the right. And of course, when we look for the left and we look for the right, we have to left and right. Let me think. If we have one going right, if we have a pattern of right, left, right first and then left, then something will converge. If we have a left, right, then they will separate. So, for example, in here we have a left, right, another left and right. So whenever left, right, this is by itself, and this is by itself, and this is by itself, right? So we can probably using this to break down the problem into a smaller problem. Or we just say we have a left, so we go, we look, I mean, if we have a left and it screams stack in my head, but I don't know how I'm gonna do it. So let's say if we have anything that is a stand still or a left, we push into the stack. So if it's a stand still, right, I push in the stack. We have a left, we push into the stack, and then we look for the one below us. And if the one below us is stand still, then we turn that into a left, and then we keep pushing, and then we have a right. If we have a right, and then push, and if it's a right, we'll turn out to right. We push, we'll turn to right, and then push to the right. And then we have something on the left. And then, no, oh, that doesn't feel right. That doesn't feel right to me. I think we have to find pairs. Right? A right-left pair is something just converged together, right? And then depending on how many is in between, and then we can have either this situation or this situation, right? This will give you some hint there already. And we have a right-left. How about we look for a right-left pair, right-left combo, right? When the smallest right-left combo, we start from there. So how do we find the left-right combo? If we talk about the smallest, that means we want to find the smallest right-left combo that doesn't have another left or right in between. So let's say we scan through the entire thing and we locate the left or right combo. So let's say we find it has to be left and right, right? It has to be left and right. Yeah, so they're either left or right, or it's just going to be left by itself or right by itself, right? That's the only, yeah, because you only have a left and right. They either pair or they don't pair, right? So we just find all the pairs. We find all the pairs, and meanwhile we can find all the non-pairs. Right? And then we're looking for a right and then to a left. So if we go through and then we find a left by itself, that's a single left. So everything to the left of that will all be left. And similar thing, if we find a single right, there's no left, everything towards, well, yeah, that's it, right? Like, the only situation of this and the only situation of the other way is the left is here, right is here. And that's the other situation. And everything else, we can always, right, no matter how many left or right we have. Actually, that's not true. That's not true. We have a, oh, hold on. If we have a right-left, we have a pair. And everything that's not paired will have everything to the right of it will all be right. Or everything to the left will all be left. That's just non-paired. So, okay, so what we try to find is the pairs, right? We want to try to find the pairs, which means we're gonna do still gonna do stack. I think we can use stack. So we keep pushing, right? We're pushing everything in. So we push if it's empty, it's standing still, we don't push, right? We don't push standing still, and we only push left or right. So, and also we, in addition to pushing, we also push the index, right? We push the index. So we push a left. If we push a left and there's nothing in the stack, that means everything before is going to be all left, right? And then we keep pushing, and we find, and then we pop it, and then we go the output. And then we push in a right, right? If we push in a right, and we keep pushing, and we find another right, then everything in between will all be right. And we pop it, we keep going. And of course, if we're pushing for a left, everything to the left will be left. If we have a left in, yeah, if it's a left in, if there's no right inside, then everything will all be left. Right? Everything will all be left. we need to record like the current. Yeah, the current. Like if I push left, and when I pop, right, we need to record the current position. I record this position, and then when I'm pushing right, and everything in between this and this will be standing still. And then we keep push. These we don't push. I'm pushing a left, and when we push a left, we see there's a right in it, and then we just compute. Everything will be right and left, except for the middle one, depending on whether we have even or odd number, and then we pop both, and then we push right in, and nothing in it, nothing is in it. That's fine. That's what we expect. Yeah. So it's very clear. When we push left, right? Whenever we push left, there's only two situations. One is there's a right in the stack, and then we can do the right-left combo. Another situation is nothing is in it, right? Because we won't have a left in it, right? So there are two situations when we push left, and we have solution for both. When we push right, the situation is there's a right in it already. If there's a right in it already, we compute everything to be right. If there's a left, there will not be a left. The left will not be in the stack. So either a right in it or it's empty. And then if that's the case, we just keep it going. I think we have something, but I really need to go. I'll be back very soon. Alright, I'm back. I think this one can be solved in ON, and we have to solve in ON because the size is 10 to the 5th. If not ON, we will have time limit expiration error. Alrighty, let's take a look. Yeah, because this reminds me of the parentheses. Similar concepts. Different questions for sure. Different requirements as well. So I'm gonna have a stack, and then we're gonna have the pre and a current, right? So pre, the position is going to be -1 actually, I think, and for for current, let's just call it j. J is -1. For I in range. All right, let's not do this. Let's do a better one. D in enumerate dominoes, right? All right, so here's what we do. We say if D is equal to a left. If D is equal to, and then we have a rest as well. Which one would you think would be faster? I think we just do string. Creating string will be faster. I hope. So if D is a left, we need to check. I say if not stack, then stack. Oh, then we don't do anything. We everything will be from J to I will be all left. So we're gonna say rest plus equal to left times I minus j, right? We don't have to plus 1, we're just I minus j. Let's see if that's correct. So j will be minus 1, so 0, 1. 1 minus 1 will be 2. That's correct. If what is j? J is the one that the last one we have encountered, right? So the last one that we have of the index of the current ones inside. So if I say this one's the current one that's no, it's not the current one's inside. It's what we have created so far. So it's gonna be a here, right? So if we do this, yeah, I think that's true. So if not stack, we're gonna do this. Else, which means stack has R in it. Else, then we have a right-left pair. That's the pair. That's the pair. Right-left pair. Then rest is gonna plus equal to. Now that is gonna be interesting. So what we're gonna do is J is going to be the previous, right? The current index, the end of rest. At the end of rest, we don't need J, honestly, right? We just need the length of rest. Yeah, I don't think J is necessary. We can use len rest, right? So I minus len rest plus 1, right? All right, so now we have that. So len rest minus 1, we get the index. So we know how many we have, right? How many we have. And then we're just going to divide it by 2, right? Divided by 2. So the length is going to equal to I minus, oh, the length is the same, right? That's the length. That's the length that we need to populate. And we can say it will be R times length divided by 2 plus, well, we don't know plus what, and then plus left times our length divided by 2. It's not in the middle, right? It's either empty or, so we're gonna say plus this if length is an odd number, right? Like here, 1, 2, 3, 4, 5. Else, gonna be this. So this is rest plus equal to this. All right, so we handle this situation. Now we're gonna handle Aleph. D is R. If not stack, stack dot append D. Else, again, stack has R in it. If stack has R in it, then everything in between we will turn into a R. So I'm going to say rest plus equal to R times I minus len rest. Well, we don't plus 1 though, because we have R, and now we have a new R coming. Now I pointing to the new R, and I minus len plus 1 is the new R to the end of the rest. We have that, so we have to do minus 1. So I think it's just this. After we do this, stack dot append, which actually we can do this, which we can actually do this, right? Move things around, because we're gonna whenever we find R, we will push it in no matter what, because we have to do this as a change, right? Stack dot append. Else, if it's a dot, then we don't do anything. So once they're done, we're gonna return rest. Okay, so I can do this one higher up. If this, then we can say length equals this, and times the length, right? And then else, we're going to do length divided by 2, and this, and this. Okay, let's try it. Oh, actually, it's not right, because the rest is not yet. We still have something left. So we're going to say if stack, we can do this. So res plus either r, if r times len dominoes minus len res. Right, that's just the remaining. Right, the remaining. When do this has to be a parentheses. Right. If stack, let's do this, remains equals this minus this, right, that's the remains, and we say res plus this times remains if stack, else if there's no stack, then the remaining will all be this. Okay? Alright, now let's try. The first test case is rr.l. We're going to return r.l. No change. Second one is, let's copy this. And then this one will turn into this. Alright, let's make sure these two pass. And I have some new ideas, like other ideas for testing this thing. So dominoes, push, dominoes, dominoes. Try it. Oh, we passed the first one, but we failed the second one. Oh, that doesn't look right at all. L, L, R, R, L, L, R, R. I think we have an issue with too much R's in it. Okay, let's see. LL is right? And then we don't do this, and now we have an R. And then we just pushed R in it. And then blah, 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 then we have an L in it. Then this one is not pushed in. Interesting. So, and what happened? The length is not right either. Because for LL, this shouldn't be R. And RR, this should be dot. I say length divided by 2. Which means we get length is this thing. The entire thing. Which means the length is wrong. Hold on. So after the first L, right, times the length, which is 2, right, which is 2. So we got 0, 1, which is 2. That's fine. And the next one is not, the next one is R. So 0, 1, 2, 3, R is 3. And then that is the first one. So we say if stack, but stack is empty right now because I didn't push anything to the stack. So we just stacked out a pen, so it's out a pen like this. And blah, blah, blah. So 0, 1, 2, 3, 4, 5, 6, 7. No, 7. L is 7 coming in. So the length is going to be 7. Ah, I see. I stopped at here. Okay. So we have to push in. Okay. I see. So this if stack, we're gonna do this, right? I'm gonna say else. If not stack, then res plus equal to star times, because nothing's in the stack, right? Which means everything is fine. So we need to push, it's not star, it's dot. How many dots we need to push in? Current I minus len res. Yeah, because not including myself. Not including myself. Okay, that's reasonable. And I actually want to change the order because just to be uniform with the previous, right? So when you say if not stack, do this, else if stack, and do this. So this one we can solve the problem of right, we can solve the problem of this one. And then when we push, it has to be append both things, right? So append I into it. And if not stack, we'll do this if stack, right? And then if not stack, we have to do this. And let's not do this here. Else, if it is, then what we're going to do is we're going to say the j equals, and then we never really pop, right? We need to pop it. J should be stack.pop. And we will need this, stack.pop. Now we have a j. Now the length is I minus j plus 1. That's the length. Then we do whatever we need to do here. Okay, now let's try it again. Now both pass. Yeah, just a little bit tweak we need. But before we go for the glory, I would like to try something a bit different. So instead of R, let's put this one R, right? So what I'd expect is everything will be R after this position. Your answer, and I think this is correct. Let's give it a shot. Submit. Oh, I didn't test the one case. No, we got a wrong answer. Hold up. Hold up. So this answer should be the same, right, left. Yeah, answer shall be exactly the same, but mine is not. So we push R, and it's all fine. And the problem is we have something to stack. I say if stack, then we do R. Otherwise, we do this. So it means we have something to stack. But the last one is L, and L comes in. We'll pop the stack. Oh, I never pop here. Else, stack has R in it. Then, well, if the stack has R in it, then if stack has R in it, we guarantee that if not stack, we do whatever we have, and then if we have an R in it, then means all these, so it's going to be R, but we need to pop. We need to pop the stack. So we need to say stack.pop. I forgot to pop here. So every time the stack has something that we need to pop, either we use it, or in this case we don't have to use it. But we can't use it, yeah, because we push it in. Let's use it. j equals this, right? And we're just going to say equals I minus j, because I don't want to include myself, right? It's just before me. This one will pass. And then we append again. So a little bit different. All right, try this one. Pending, judging. This one will pass. So just a little bit trick. Yeah, we forgot to pop. This problem reminds us of matching parentheses. We use a stack to keep track whether there is an unmatched R. So if the current state is L, there are two scenarios in the stack. Stack has an R or stack is empty. If stack has an R, then we know from the R in the stack to L, we can form an enclosed pair, and the states of all dominoes within this enclosure can be easily computed. If the stack is empty, that means everything from the current end of rest towards L, towards the current L, must all be L. If a current, not state, current domino, if the current domino is R, there are the same two scenarios. If the stack has an R in it, then everything from that R towards the current R must all be R. If the stack is empty, then we simply then everything from the end of rest towards the current R must all be dot. If the current domino is dot, we skip. So it runs in ON, right? It runs in ON, and that's that. So slightly a little change. So now we have the length. We pop it, we compute the length, we do this, right? And then here, if not stuck, one is at L, the other is at dot, which is fine, but the length is slightly different because this one we need to append. Oh, why do you append D? There's no point of append D. All right, we just need to append I. All right, this is append I. And then this we can just simplify it. Dot pop. So that's going to be I minus the pop. That's the length. Right? And here the same thing. Stack.pop is going to be here. Right? That's the same. And then remains is whatever remains. And we say for the stack. Yep. Alright, let's take a look at what is the runtime on this. 204. Actually, I'm going to try this one again. Might be faster, slightly. We're talking about instead of pushing a tuple, in this one we're pushing a single. Let's try this one first. Okay, pass here. We're pushing a single value. I'm pushing a single value. So I hope this one is actually going to be faster. Okay, this one give us 184. See, this, instead of pushing a tuple, we're pushing a single one. That's much faster. So 184 milliseconds, which give us 60%. All right, pretty happy. 60%. All right, now it's time to look at medium question 838. So LeetCode 838. Give it upvote. I like this one. Try it 3 times. Okay. Oh my, look at how simple it is. Calculate force. Adjacent symbols. Calculate force. What do you mean by calculate force? Anyone come up with a second is a freak. Confusing as usual. Alright, let's take a look. Maybe they have different ideas than I do. But in every group of vertical dominoes, we have up to 2 non-vertical dominoes bordering this group. Since additional dominoes outside this group do not affect the outcome, we can analyze these situations individually. There are 9 of them. As the border could be empty. Actually, if we border the dominoes by L and R, there are only 4 cases. We'll write new letters between these symbols depending on each case. I didn't understand anything. If we have, say, A to B, where A equals to B, then we shall write OA. If we have RL, then we will write RL or R if we have an odd number, even number. Check our distance, determine what to write. If we have LR, we don't do anything, we skip this K. That's true. So, symbols. So we get the index and we push both on the outside. And then answer equals list dominoes. That is true. And when we zip symbols and symbols 1. Interesting. We zip symbols and the symbols 1. That means we are saying we're finding the pairs, right? That's what we're trying to do. We're finding the pairs. So if we are finding the pairs, we're finding every pair, every possible pair. So we say this is a pair, this is a pair, this is a pair. Ah, I see. We remove all the dots because dots don't mean anything to us. So we just have LR, something like that. And then all we want to know is the pairs. And that's how you get the pairs. And then we put 2 on both sides and we would reduce the number of cases. Yeah, so it's either LL, LR, RL, or RR, right? And then we say if they're the same, then we fill it the same. So for this range, we fill it the same. If it's larger, that's R, L, then we have to do this. Oh, what the hell is CMP? What's CMP? CMP. Compare? How to use Oh, Python 3 doesn't have CMP. What is CMP? Doesn't exist. Taken from the original. Let's just ignore it. Let's just compare function. Oh, I see what it's doing. So we can choose. Either use this, or use this. Just a smart way to make the choice, right? Because on range this to this, that's the ones we need to worry about, right? Yeah, that's the one we need to worry about. And I always say, for the current one, if it's larger than I but smaller than j, we use how do we figure? It has to be 0, 1, and 2. Oh, minus 1. 0, 1, or minus 1, right? So if this is smaller, this is bigger, let's say we return minus 1. If this equal, we return 0. If this, and we return 1. See, okay, good solution. I think I'm gonna implement this one. Let's read the second one. We can calculate the net force applied on every domino. The forces we care about are how close a domino is to a letter R, and to a leftward R and a rightward L. The closer we are, the stronger the force. Feels like talking about Star Wars, huh? The force. Scanning from left to right, our force decays by 1 every iteration and resets to n if we meet in R. So the force I is higher than force J if only if dominus I is closer to R than dominus J. You can find a force going toward close to L. And for some domino I, if the forces are equal, then the answer is Otherwise, the answer is implied by whichever force is stronger. Oh my god. Okay, so we find the forces go left to right. Force decay by 1, and then resets to n if we meet in R. So that's 7, 6, 7 again, the force, and then decrease, just keep decreasing, right? 7, 6, 5, 4. A 0, 7, 6, 5, 4. But if I reach L, we get a 0. Decay by 1 after every iteration, and then resets to n if we meet in R. That force I is higher than force J if and only if dominus I is closer to R than it's towards than dominus J. Okay, that makes sense. And if it's L, then we just set to 0 and go reverse, right? If we go reverse, right to left, then we go minus. Oh, I don't have to do minus. They can be 7. Right? Why would we do minus? I'm taking the vector addition. Oh, we have to know which one's which. Okay, so it's force is negative. So negative 7. R is 0. And this discontinuation 0. Which means this has the force. The largest force going left. This is the largest force going right. And everything in between just decreasing. Like at this position, the right force is now 6, the left force is 4. And we add them together, it'll be this. And if it's larger than 0, that's going to be R. The 0 is a dot. Oh my. Oh wow. This is, how should I say it? I don't know. I don't know how do I feel. It's very interesting. Very interesting solution. Yeah, it's a freak. All right. A force. Interesting. All right, I'm gonna implement both, just for fun. Simulate process. What do you have? Keep 2 pointers. Oh, I think this is the same as the original solution. Would that be easier to handle? I mean, I have more. Div mod, that's the one. That's the one. Yeah, I'm stealing it. I'm stealing it. No, it's been quotient, and remainder equals div mod. I need to use div mod, and this is just going to be times quotient, and this is going to be times remainder, and this is going to time quotient as well. Yeah, div mod. I need to use div mod. This is the same solution, right? So we just left our right. We add this, and then we just go through. We find it, and then figure out what it is, and left push it here, right push it. I'm actually going to do it this way, because this is less memory intensive. I'm going to upvote this guy, and I'm going to call it stack-ish, because it doesn't really have to be a stack. We only push an I, so I can just, instead of say stack, I can just say, yeah, let's keep a stack. Yep, I'm gonna publish this for fun. New, all right, follow my, Python 3, stack ish solution. It's not technically a very serious stack, because it's only have one value, and the maximum number of values in it is 1. Right, it's 1. So, anyway, so yep, post. All right, now it's time for us to write those two solutions. All right, so the first one, this is going to be, this is the same concept as the first solution in the official solution, but we will do it, the other way. We'll do it in the way of Bobby Chiff. I have a new guy now. A new guy now, in the way of deep Bobby Chiff. But of course, we're not going to copy and try to do it ourselves. So pushing here, and let's write ourselves. So basically, the idea is to find. So the basic idea is to find LR pairs. It can either be LL, LR, RL, or RR. And for each pair, we can easily compute the state of the dominoes in between. We ignore all this dominoes at the beginning. Also, we need to add dummy, domino, dominoes L and R to the left and right side, respectively. Alright, now let's do this. So we're gonna have to say a item J, right? So dominoes equals, yeah, L plus dominoes plus R, and ij equals 0 and 1, right? And we now also have a res equals this. We say for, what is that? We just have I equals 0, j equals 0. I like to have j equals 0. I'm going to put them together. Res is this, j is this, j is 0. So that's the dummy. And for I in range, I'm going to go 1 towards land dominoes, right? And we say if dominoes, why do you do that? That's fine. If dominoes I is equal to, if dominoes I is equal to dominoes j, right, they're the same, then we say res plus equal to dominoes I times, what's this? That is going to be I minus j, right? Same. I minus j. We don't plus 1. Good question. So j is at the front, right? So it has to be minus this. Yeah, that's fine. Right? If it's same, I minus j. That solves the problem. And if we go to the end, and where is j going to be placed? J can be placed at the one that we have found already. Hold on. So after that, J has to move, right? J is moving to here. And then if we find the same, and then we go this minus this. I think that's correct. So if it's equal, we do this. Aleph dominoes I is, so we only care about oh, we have to move J. So J equals I, right? And then we find, what if we have L and R? Right? If we find L and R, then, yeah, I think we have to consider all three situations. Right? If domino I, if that as R is larger than domino J. Right? So this is a situation of R. No. No. This is smaller. That's going to be RL. So the RL situation, we're going to have quotient and rem. That's quotient and rem equal to div mod I minus J. Now I minus J is going to be, hold on, I minus J. Oh, we have a little bit issues here. I minus J. J is already done, right? J is already done. And then, oh, what you're saying is we don't do the J yet, right? That's what you're saying, right? We can, because if we have R and L, and R is done, L is not done, which is fine. We just do I minus J minus 1, right? I minus J minus 1. No, that's not right. That is not right. Because it's from R to J. We have to count the number from R to J. Therefore, we cannot fit the current one. If we do not fit current one, where do we do the current one? Always in the next one? Let me think again. Because the initial J is something we cannot include, right? So this J is not including. And now we have the current R, right? And then we say we want to do everything in between. How can we do everything in between, right? We do just from the current R, current all the way to previous, right? Current all the way to previous. But and then we move the J towards the current, which is actually the end. Now we move the J here. Now when we move the J here, is that the same? L and L or R and R, and we move after we're done, right? We put those in and we move R and R, we'll move it here, and then now we have this situation in RL. the R is already counted for, right? The R is already counted for. The L has not been counted for. But it has to be both. I think I know. So we have to do +1. We have to include the R while we compute this. So we include R when we compute this, and when we add, rest plus equal to R times quotient minus 1, because we already did it, plus this times remaining, and plus L times quotient. So that is the right side. We're including L. And after we do that, J equals I. And else, in this case, if we have to escape. If dominoes I is equal to dot, then we continue. Make sure we don't do that. And then we can call else. So this is an LR situation. So if it's an LR situation, then everything in the middle will be dots, right? Which means res plus equal to dot times I minus j minus 1, because we don't include the current one, right? We don't include current one. Oh, we do not include the current one? That is going to be trouble if we don't include the current one. Because our premise is we always include the current one. So yeah, we have to include the current one. So plus equal this plus the current one. What's the current one? And R. So we have to include R in this one, because J has to equals I. Remove J equals I. And return the rest. No, I don't like it. We shouldn't include the current one. But we have to. If we don't include the current one, that actually makes things more complicated than it's supposed to be. I actually prefer handling this in an array. I think array will be easier to handle. What do you think? Because it's the same, right? Then we have to go the middle part. There's a question of where do we include the ones. This one doesn't look right because we add an extra R. I mean, imagine we have R and all the way to R. Then we add this, which is in the middle. And unless we don't go to the end. Now, if we don't go to the end, what if it's R and R? We have to go to the end. If we go to the end, all right, this is an LR situation. LR situation. What if we have L and we have R at the end? Then it should be everything in the middle is this, and we add this R. I don't want to add on the right side. So if we don't add on the right side, we have to add on the left side. Let me think. What would be the better way of doing this? How about we don't add either side, right? If we don't add either side, and we find the first one. Oh, hold on. We can add to the right side. We just return, don't include the last one. Because in this, we always include the last one. Right? The last one will always be R. So it's LR or RR. If it's RR, so yeah, I think we just return, don't include the last one. I'm not sure. Oh, it passed. Okay, so this solution always always includes the right side. How should I describe it? Best way is put it here. We always include the right side. So the so res is one bigger than it's supposed to be. Yeah, that's the only thing I can say. Whether it makes sense or not for the future self. The right side of the LR pair. The rest is one bigger. Right? It's one bigger than it's supposed to be. Alright, let's try it. Alright, run it. Yep, it passes. Alright, solution 3. It's the last one we're going to try. Solution 3. the fourth solution from the official one. Force equals 0 times len dominoes. Alright, force of R go from left to right. So what we're going to say is N equal to len dominoes. Alright. And then what we're going to create is for I, D enumerate dominoes, right? And we say, actually, I just need to say for D in dominoes. I don't need to enumerate. And starting F is N, right? And we say, oh, we do need I. We need to enumerate dominoes. So we have to populate the force, right? And say if D is R, then force I equals F. No, equals N. We can actually do F equals N, and at the end we always say equals F, right? If this else F minus equal 1, right? F always decreasing, and then we record the force. If it's R, Aleph, D is equals dot, then we do this. And if it's, what if we encounter a left? And then it's all 0, right? Else F equals 0. If this equals this, and this, actually it's different. If F we can say F equals the maximum, F minus 1, and F minus 1 is 0. Which means if F is 0, we remain at 0. Otherwise, yep. So force going to be this. And now force of L go from right to left. Again, for I in range n minus 1, minus 1, minus 1. If dominoes I is equal to L, F equals minus n. Right? Aleph dominoes I is equal to dot, then F equals minimum, F plus 1 is 0. Yeah, if it's 0, we always 0. If it's not, we're going to take this. Else F equals 0. And then force I plus equal to F. Plus equal to F. Actually, we need to initialize F here as well. Right, so plus equal to F. Now we're going to say return dot join for F in force, and this one is going to be R if F is larger than 0, else this if F is smaller than 0, else dot. So this is going to be left. Okay, the false solution. Nope. Incorrect. Let's see. Why is it not correct? We passed the first one, then pass the second one. Let's see the force. Print force. 13. That was 13, 0. 0. And the beginning is go 14, 13, 12, 11, 0. 14, 13, 12, 0, 0, 0. Huh. I have negative. And force as well. Let's see. This one is 0. Minus 13. Minus 12. Well, aren't these supposed to be zeros? I think these are supposed to be zeros. We start with the 0. Start with the 0. Yeah, there we go. We start with the 0. And once we reach an R, then we turn. Okay? Yeah, start with no force. There we go. Just sum it here first. Hold on, let's copy this one. Solution. Alright, sum it here. Solution. Oh wow, this one has 400 milliseconds. This one's slow. You have to go it twice. But it's interesting. It's interesting. And also you have to, I said 3 times. Alright, that's it. So interesting solution. Interesting solution, but kind of slow. 400 milliseconds. Alright, that's it. That's it for today. We did pretty well. Our solution is different from what is considered the official one. Alright, see you guys tomorrow. Adios.